21st century breakthrough promising to shed light on some of the most mysterious secrets of our universe has been announced in the last few hours.
Ladies and gentlemen, we have detected gravitational waves. We did it.
The theory of gravitational waves describes disturbances caused by colliding space objects like stars. The possibility of their existence was first predicted by Albert Einstein a century ago. The idea of using special detectors to find the gravitational waves was first discussed by Soviet scientists back in the 60s. Kip Thorne, one of the leading researchers on the matter, spoke to RT shortly after the historic announcement, and he told us that the Russian contribution just cannot be overestimated.
Well, they're important. The contribution was very important as the initial outline of the idea of this method, but a much larger contribution to our effort has come from the research group of Vladimir Braginsky at Moscow State University. Professor Braginsky had built a different type of detector, the type that was pioneered by Joseph Weber in the United States. We now have 16 nations involved in this, but the Russian contribution goes back almost to the beginning and has been truly crucial.
Scientists now foresee a new chapter in astronomy, allowing them to observe previously obscured astrophysical processes and objects while answering important questions. The breakthrough should also give insight into mysterious black holes and let us know if travelling inside one could be possible, as portrayed in the blockbuster movie Interstellar. Kip Thorne, again, who was an advisor on that movie, says that fact is now far surpassing fiction.
So I believe that humans will ultimately do missions to black holes. Very, very unlikely that anyone will ever go inside a black hole and survive. We're not 100% sure, and in the movie Interstellar it does happen, and I explain in a book I wrote called The Physics of Interstellar. I explain how it happens, but that's speculative. We don't understand the interiors of black holes well enough to know whether that could really happen. It probably can't. But what we have seen today is something that in some ways is more fantastic. It's not just a black hole there that you're studying. It's two black holes that go around each other, spiral together, and collide. And in that collision, they create something that we have never, ever seen before as humans, as scientists, as astronomers. They create a storm in the fabric of space and time. You know, it's as though we had never seen the surface of the ocean on a calm day, or we had only seen the surface of the ocean on a calm day. We had never seen it in a storm with crashing ocean waves. Similarly, we had never seen space-time with wildly oscillating rate of flow of time, wildly oscillating shape of space. We had never seen that before. Now we have seen it both in computer simulations and in observations with this gravitational wave detection. It's a whole new way to study the universe, a whole new way to probe aspects of black holes that we didn't understand until now.